The aim of this example is to take this expression and write it as a single logarithm. That means one term which involves a log. And we'll need to apply a variety of log laws and basic operations for us to do that. So it's suggested that what you do is you take a copy of this, and as we go through the video, pause at each of the steps or operations that actually simplify this expression to a single log. We'll start by looking at the brackets. We can see that inside the expression we've got 3 log base a of 2 plus log base a of 5. And because that's in the brackets, order of operations says to tackle that first. And what we have here is a sum of logs. But we also have the number 3 at the front of the first log expression. And if we revisit our log law from before, we can see that if we have a sum of logs, we know that they combine to form one log with the product of the terms, in this case m and n, but there are no values out the front of the logs. So going back to our original example, if we're to apply the log law involving a sum of logs, we need to somehow remove that 3 so that we just have a sum of 2 log terms. And we do that by using a log law which says that if we have a number at the front of a log, we can bring it inside the log. So in this case it becomes log base a of 2 to the power 3. We can now simplify the expression in the bracket because we have a sum of 2 logs. And we can rewrite that as the log of base a of 2 to the power 3 multiplied by 5. So we have a single log replacing the sum of logs. And of course that's a simple calculation because 2 to the power 3 is 8 and 8 multiplied by 5 is 40. So the expression becomes log base a of 80 minus log base a of 40 minus 2. It's important to note that we could use that log operation because we do have logs with the same base, in this case base a. Now the next step is to recognize that moving left to right in our new expression we have a difference of 2 logs with the same base. And we have a log law which says if we have a difference of 2 logs with the same base, we can rewrite that as a single log expression where inside the log it becomes, in this case, as we can see from our original log law, m divided by n. So simplifying our example, we can see that we've got a difference of 2 logs where we have the value of 80 and 40. And the division of those two numbers gives us a log base a of 2. We now have a little bit of a problem because we're trying to write this expression as a single logarithm, but what we have is a log and then we have a whole number separate to it. What we need to do is create a second log so we can incorporate a log law, and we can do that with any whole number. In this case what we're going to do is multiply the number 2 with log base a of a. If you have any log where the number inside the expression is the same as the base, that's equivalent to 1. So we're going to multiply 2 by log base a of a. Then what we do is we incorporate the log law with a power. We're going to bring that 2 that's outside the front of the second log and put it inside as a power, so we have log base a of a squared. And that allows us to finish off the expression because now we have a difference of logs, and we can rewrite that as a single log, in this case log base a of 2 divided by a squared. And now we have an expression written as a single logarithm.